Hold on to your physics textbooks. Scientists just shattered our understanding of how magnetism shaped the earliest moments of our cosmos. Imagine discovering that the invisible forces that helped birth every galaxy, every star, and ultimately every planet in our universe were so incredibly weak that they make a simple refrigerator magnet look like a cosmic tower house. That's exactly what an international team of researchers has just revealed about the primordial magnetic fields that existed in our young universe. But here's where it gets mind-bending. These ancient magnetic fields were literally billions of times more feeble than the magnet holding your grocery list to your fridge. To put this in perspective that will make you question everything you thought you knew about cosmic forces, we're talking about magnetism so delicate, it's comparable to the tiny electrical signals firing between neurons in your brain right now as you read these words. A groundbreaking collaboration spearheaded by CISA, the International School for Advanced Studies in Trieste, Italy, joined forces with brilliant minds from universities across Hertfordshire, Cambridge, Nottingham, Stanford, and Potsdam to crack this cosmic mystery. Their weapon of choice? An absolutely staggering 250,000 computer simulations that modeled how these whisper-thin magnetic fields behaved in the primordial universe. Lead researcher Mak Pavicevic, a PhD student at CISA, worked alongside co-author Matteo Viel to unravel one of the universe's most perplexing puzzles. They focused their investigation on the cosmic web, that incredible filamentary network that connects galaxies like a vast, three-dimensional spider's web, spanning the entire observable universe. Think of it as the universe's highway system, except instead of connecting cities, it links entire galaxies across unimaginable distances. What truly baffled us about the cosmic web, Pavicevic explains, is discovering magnetism in the most isolated, empty regions of space. Areas so remote and sparsely populated that finding any magnetic activity there seemed almost impossible. We theorized that this magnetization might be an ancient fingerprint left behind by processes that occurred during the universe's infancy, potentially during the inflation period before the Big Bang or during subsequent cosmic phase transitions. And this is the part most people miss. When the team compared their simulations with real astronomical observations, something remarkable emerged. Models that incorporated these incredibly weak primordial magnetic fields matched observed data far better than models without them. The sweet spot, a magnetic field strength of approximately 0.2 nanogauss, a measurement so small it challenges our everyday understanding of what weak really means. Vid Ersik from the University of Hertfordshire couldn't contain his excitement about the scope of their work. These represent the most realistic and comprehensive suite of cutting-edge simulations ever conducted on how primordial magnetic fields influence the intergalactic cosmic web. We're essentially watching the universe's magnetic history unfold through computational archaeology. But here's where it gets controversial, and this might spark some heated debates in the scientific community. This research establishes a dramatically lower upper limit for primordial magnetic field strength than previous estimates suggested. We're talking about constraints that are significantly more restrictive than what many scientists had theorized. Some researchers might argue that such weak fields couldn't possibly have had meaningful cosmic influence, while others contend that their very subtlety made them the perfect sculptors of cosmic structure. The implications are staggering when you really think about them. These gossamer-thin magnetic threads may have been the invisible architects that influenced the density patterns of the cosmic web itself, potentially accelerating the formation of the first stars and galaxies. In other words, these barely there magnetic fields might have been the cosmic matchmakers that brought matter together in just the right way to ignite the first stellar nurseries. The research team's findings, published in the prestigious Physical Review Letters, align remarkably well with independent measurements from the cosmic microwave background, that faint afterglow of the Big Bang that still permeates our universe. This convergence of evidence from multiple sources strengthens their conclusions significantly. Looking toward the future, the James Webb Space Telescope, humanity's most powerful eye on the cosmos, may soon provide additional confirmation of these findings. Imagine peering so deep into space and time that we can actually observe the fingerprints these ancient magnetic fields left on the earliest galactic formations. But let's pause for a moment and consider the philosophical implications. If magnetic fields billions of times weaker than what we encounter in everyday life could shape the entire cosmic web and influence galaxy formation, what does this tell us about the delicate balance of forces that made our existence possible? Are we living in a universe where the most subtle influences create the most profound effects? This discovery raises fascinating questions that deserve your thoughts and opinions. Do you find it incredible that such weak forces could have such massive consequences? Or does this make you wonder what other invisible, barely detectable phenomena might be secretly orchestrating cosmic evolution right under our noses? And here's the big question that might keep you up at night. If scientists had to run 250,000 simulations to understand these effects, what other cosmic mysteries are we still completely missing? Share your thoughts. Do you believe that the universe's greatest secrets lie hidden in its most subtle forces? Or do you think there must be stronger, more obvious mechanisms at play that we haven't discovered yet? The cosmos might be far stranger and more delicately balanced than we ever imagined, and your perspective on these mind-bending discoveries could contribute to how we understand our place in this magnetically woven cosmic tapestry.